An infinite impulse response IIR is a digital signal filter in which every sample of output is the weighted sum of only some finite number of pass output. This is the pass output, as well as current input and or only some finite number of pass input. This is the pass input. The output will not settle to a steady state within a finite amount of time. So this is the equation of IIR, output in time domain. And this is the equation of IIR, output in Z domain. Now we move to direct form 1 structure for IIR system in time domain. Okay, please listen carefully. As usual, we have current input Xn on the left and current output Yn on the right. For IIR system, it depends not only on the current input and pass input, but also on the pass outputs. So the difference between IIR system direct form 1 and FIR system direct form 1, we have this lower part that representing this pass output. So as usual, this is as previous system of direct form 1 FIR system. We have current input, current pass input after we apply delay unit time in time domain, and we also have coefficient. And on the lower part, we have this pass output. So the pass output started from here. We have the current output Yn. So we apply the feedback path to that multiply with delay unit time for time domain to produce this Yn minus 1. Okay, so we start with here first. So for this one, this is Xn multiply with B naught. That will produce B naught Xn. The second path, Xn minus 1 multiply with B1, that produce B1 Xn minus 1. And Xn minus 2 multiply with B2 produce B2 Xn minus 2, and so on. So for the lower part that involves the pass output, so we have Yn here. Multiply with delay unit time, it will produce Yn minus 1. We multiply is with minus A1. For this one, we need to multiply with minus A1. Since this, from this direct form 1, we will produce Yn. In order to have Yn, we need to rearrange this part that involves pass output. We should take it to the right side. So all the coefficient will become minus A1y minus A2 minus An. Okay, so in this direct form 1, so we need to use symbol minus A1 for the coefficient for this part of pass output. So we have this pass output Yn minus 1 multiply with coefficient negative A1, so it will produce negative A1 Yn minus 1. So the next part is Yn minus 2 multiply with coefficient negative A2, it will produce negative A2 Yn minus 2, and so on. Yn minus n multiply with coefficient negative A and produce negative An Yn minus n. To read this equation, to produce this equation, Yn is equal to B naught Xn plus B1 Xn minus 1 plus B2 Xn minus 2 and plus Bm Xn minus m for this part minus this part. Okay, minus A n Yn minus n minus A n Yn minus 2 minus A1 Yn minus 1, or you can rearrange in this format. The next one is direct form 1 in Z domain. We have this equation. This is the current input Xz and this is the current output. The top part is for current input and pass input. The lower part is for pass output. So in order to produce this equation Yz, this part of pass output, we rearrange and take to the right side, so all the coefficient will become minus. So for this direct form 1 in Z domain, we have x multiplied with b naught will produce this one. Z minus 1 x multiplied with b1 will produce this one, and so on. Okay, for this one, this is yz. After we multiply the daily unit time in z domain, it will produce z minus 1y. Z multiplied with coefficient negative a1 will produce this one. The next part is z minus 2yz. After we apply double delay unit time in z domain, multiply with negative a2, it will produce this one, and so on. So yz equal to b naught xz plus b1 z1 z minus 1 xz plus b2 z minus 2 xz, and so on, plus this part which is negative a z minus 1 yz minus a2 z minus 2 yz minus negative a n z minus 1 yz. And after you rearrange this equation, all this part, the top part and lower part, you will have the same equation as this one.